Hello everyone. In the last two classes, we had studied about media access control, ALOHA and CSMA protocols. Let us just revise those. We have seen that whenever stations are connected and use a common broadcast link, we need these multiple access protocols to coordinate the access to the link. That is, to send the data over the medium. So, there are two types of protocols which will be discussed. One is the random access protocols and the other is the controlled access protocols. In the random access protocols, there is no scheduled time for the station to transmit, and also no rules specify which station should send next. That means these are random methods, and also here the stations compete to access the medium. And what happens because of this is when more stations tries to send, the result is nothing but the collision. So there are two types in the random access. The first protocol that will be discussed is the ALOHA protocol. In the ALOHA protocol, two features considered as we have discussed is there is no scheduled time for the station to transmit, and also no rules specify which station should send next. And first one in that is the pure ALOHA. So pure ALOHA here, each station sends the frame whenever it has a frame to send, and it relies on the acknowledgement. If no acknowledgement within the timeout, then it has receiver. From the receiver, the transmitter will conclude, or the transmitting station will get to know that the frame is lost, and station waits for the random amount of time, which is said to be the back of time, that is TB, with the maximum retransmission attempts Kmax equal to 15. That is what we had seen in the last class through this procedure for the pure ALOHA protocol. It sends the frame, it waits for the timeout, for the acknowledgement. If the acknowledgement is not received, then it waits for the back of time. Next is about the vulnerable time. Vulnerable time is a time during which there is a possibility of collision, and it should be always 2 times that of the frame transmission time for a pure ALOHA. That means during the 2 times that of the frame transmission time, only 1 frame should be sent so that there will not be collision. And maximum throughput can be achieved S is equal to G into e power minus 2G, and G is the average number of frames generated during 1 frame transmission time. And also we had seen that to achieve this maximum transmission, the value of G is half for pure ALOHA. That is, during the 2 frame transmission time, we have to send only 1 frame, because of which there will not be collision. And the maximum efficiency or the maximum throughput that we can achieve is 0.184. And next also we had seen about the slotted ALOHA. Here this gives or provides an improvement over the pure ALOHA. Here the times slotted ALOHA, the time slot is divided into TFR seconds, and the station is forced to send only at the beginning of the time slot. So the vulnerable time is only TFR. During that time duration, if only 1 frame is sent, then in that case there will not be collision, and the maximum throughput is achieved when G is equal to 1, which is 0.368. And also we had discussed about CSMA, which is carrier sends multiple access. Here, before sending, it senses the medium and then transmits the data. That is how it is different from the ALOHA protocol. Even it is a random access method, but just the difference is that before sending the data, it listens to the medium and then sends the data. But still there is a possibility of collision because of the propagation delay. That is, when a station sends the frame, it takes some time to reach every other stations, and for every station to sense it also there will be a time. So station may sense the medium and find it idle only because the first bit sent by the another station has not been received, and this happens because of the propagation delay. We can see here this is the time axis, and we can see that whenever a frame is sent and it is received at the receiver, there will be a delay. That's why a slant lines are drawn. Just imagine at time t1 B sends a data frame to A as well as to C in both the direction. After a time duration t2, C sends the data to B as well as to D. Then in that case, you can see here, these are the different signals. There are signals and also there is a collision which takes place. You can see here, even in this case, what happens here is B can sense here. This is only one frame which is transmitted from A to D. At time t1, a frame is sent from A, and after a time duration, some time duration, the frame is received at the station D, and it is said to be the propagation time. So during this frame propagation time, if only one frame is sent, then in that case the collision can be avoided, and this is said to be the vulnerable time in CSMA. So here to do this, as we had seen in the last class, there are some persistent methods which will tell about what should do if the channel is busy, what should do if a channel is idle. So in the case of a one persistent method, after the station finds the line as idle, it sends the frame immediately, and it is with the probability 1, and in this method there is a highest chance of collision. You can see here in the flow diagram, it continuously keeps sensing. Once it finds idle, it starts to transmit. In the case of a non-persistent method, if the line is idle, it sends. If it is not idle, that means if it is busy, it waits for a random amount of time. Here, in this case, it reduces the chance of collision because all the stations may not wait for the same amount of time. But it reduces the efficiency because the medium remains idle even when there is a chance to transmit, or even there is a provision to transmit but it is in the wait state. You can see here, the station could transmit here, but since it was in the waiting state, it senses after some time and then tries to transmit. Then in the p-persistent method, based on the probability it works. If it is busy, it continuously keeps sensing. Once it finds free, it checks for the probability of outcome, and if that probability of outcome is only less than that of p, then it transmits. If it is greater, it waits till it becomes less. So today we'll see about CSMA CD, which is carrier sense multiple access with collision detection. So here, in addition to the sensing, here collision will also be detected. So you can see here collision of the first bit in the CSMA CD. We consider with respect to the first bit. First bit of A collides with the first bit of C. You can see here. Once it is collided, it is detected and aborted. That is what is done in CSMA CD. Even here you can see A is sending in one direction and also C is sending in the opposite direction. Both the first bit are collided. At the same time, it is sent back and it is informed to A as well as C that there is a collision and the transmission is aborted. For that, there is a restriction on the minimum frame size. That is, before sending the last bit of the frame, what is done is, the sending station must detect a collision. So what we have to do, once the entire frame is sent, it does not keep a copy of the frame and also does not monitor the line for the collision detection. That is why before the last bit of the frame is sent, sending station must detect a collision and the transmission should be aborted. So there is a restriction on the minimum frame size. In the CSMA CD, the frame transmission time must be 2 times the maximum propagation time, because TP is the time it takes for the signal to reach the destination, and with respect to the effect, once the collision takes place, it takes TP time to reach back to the first to inform or to abort the transmission because the collision has occurred. So the requirement is that minimum frame size must be at least 2 TP so that the collision can be detected and it can be informed and it can be aborted, so that even the copy of the frame still remains at the transmitter end. Just the thing is, if it was fully transmitted, then in that case the copy will not be kept and we cannot transmit that data. Data will be fully lost. So before we transmit that data full, before the last bit of the frame is reached to the receiver, we have to abort the collision so that a copy will be remained at the sending station. So the TFR size should be 2 times the maximum propagation time. Let us see a problem here. In the CSMA CD, the bandwidth is given 10 Mbps. If the maximum propagation time is 25.6 microsecond, what is the minimum size of the frame? So here we know that in CSMA CD, the main thing to be remembered is the frame transmission time. The frame transmission time should be equal to 2 times that of the maximum propagation time. That is what we had discussed. TP time to reach the receiving station, or TP time it takes by first bit to reach the receiving station, which is said to be the propagation time, and TP once the collision is detected, it is the TP time to reach back to the first station. So TP is given here, which is 25.6. So the frame transmission time is 51.2 microsecond. This means in the worst case, the station needs to transmit the frame for a minimum period of 51.2 microsecond to detect a collision. So in the given bandwidth of 10 Mbps, the minimum size of the frame is bandwidth multiplied by the time. We get it as 512 bits, or it is 64 bytes. This is the minimum size of the frame for the standard Ethernet. Now, the procedure for the CSMA CD is, in addition to the ALOHA protocol, in the CSMA CD, extra is, one is the addition of the persistent method. That is what we had seen in the ALOHA. Let us move on to the ALOHA now once again. In the ALOHA, we had discussed that the stations transmit whenever there is a data, whenever it has a frame to send. It sends the frame. And also, it need not sense the channel. But here in the case is addition of the persistence method. That means it sends the channel before sending the frame. If the station is idle, what should be done? If the station is busy, what should be done? That will be decided here. And the second difference from the ALOHA is that frame transmission. ALOHA, entire frame is sent without bothering about the collision, and then it waits for the acknowledgement. If no acknowledgement, then in that case, after a timeout period, the frame will be resent, and it can use a back of time also. In case if the frames get collided, just the waiting time will be provided. But in the CSMA CD, the transmission and the collision detection is a continuous process. That means stations do not send the entire frame and then look for a collision. The station transmits and receives continuously and simultaneously. So it constantly monitors either the transmission is finished or a collision is detected. When it comes out of the loop, if a collision is not detected, that means it is a successful transmission. Otherwise, there is a collision. Next, the third difference while compared to the pure ALOHA is that it sends a short jamming signal which will inform the other stations that there is a collision occurred and you should refrain from sending the data. Or if the collision has not sensed, then because of this jamming signal, the collision can be sensed. And with respect to that jamming signal, it can have three different values. 0 if it is idle, normal if the channel is sending the frame, and if it is abnormal if there is a collision. And here the energy will be twice the normal level. You can see that when it is idle, when there is a frame transmission, whenever there is a collision, because of which stations can detect there is a collision. That is what happens when we are sensing. If a jamming signal is noticed, then in that case the the sending will be aborted. That means collision is detected. Let us see it with the flow diagram. Whenever a station has a frame to send, K is the number of attempts, and as already discussed in the pure ALOHA, even here the maximum value of the K is 15, which is the maximum attempt. Here, the difference with respect to the pure ALOHA is, here first one of the persistence method is applied. One persistent, non-persistence or P persistence to sense the medium. If it is one persistence, it continuously senses, and whenever it finds free, at the same moment it transmits. But in the case of a non-persistent, it continuously senses. If it is busy, if it is idle, if it is busy, it senses, it waits for a time duration, then once again it senses, it waits for a time duration, then it once again senses. It will not sense continuously. So, maybe the efficiency is reduced because during that waiting period, if the channel is idle, then that bandwidth will be wasted. In the P persistent, based on the probability of outcome, if the probability is less than that of P, only in that case the station is allowed to transmit. Otherwise, it is made to wait till that back of time. Now, once it is eligible for transmission, transmissions will be done. If the transmission is fully done and if there is no collision detected, then it is a successful transmission. If the transmission is done and if in the case transmission is done and the collision is detected, then the station sends a jamming signal, and this jamming signal will be sent, and to send the next data, it has to be in the back of time. It has to complete that back of time. And in the similar way, 15 attempts, K maximum will be 15. So till those many attempts are provided, and after that once again the station senses the medium. So here what we have to remember is the three differences. First difference is addition of the persistence method. Second difference is the frame transmission, and the third difference is sending a short jamming signal, because of which the collision will be detected. Once the collision is detected, it has to wait for some time, which is a back of time. Then it has to once again start with the sensing the medium. If there is a detection, then send a jamming signal. If not, transmit it in a normal way. And CSMA CD is considered to be throughput obtained will be greater than that of the ALOHA protocols. So here maximum throughput occurs at a different value of the G based on the persistent method and the value of P in the P persistent approach. For one persistent, the maximum throughput is 50% when G is 1. For non-persistent, maximum throughput can go up to 90% when the value of G is between 3 and 8. In the next class, we'll continue with the CSMA CA, which is carrier sense multiple access with collision avoidance. Thank you.